Welcome, algebra students. We are now on to linear application number 6. Hopefully you've had a chance to do a couple of them on your own. You've gotten a little feedback and you're getting a little bit better with it. So on this one, we're going to be talking about how they build roadways, and in particular, bridges. So pretend that these two ice cream sandwiches, pretend these are like two sections of roads. You might think they just put them like this, right next to each other. But the problem is, when the weather gets warmer, things expand and things get bigger. When it gets colder, things shrink. So the problem is, if they put them too close together and then the weather gets warmer and warmer and warmer, there's nowhere for these to go, and then they just buckle, and then the road kind of, blows up. So what they do is they intentionally put a little gap in between them. So when the weather gets warmer, it expands, gets bigger and bigger and bigger, so they get close to each other, but they don't start to buckle. So they intentionally put little gaps in the roads to adjust for the differences in temperature. And I'm going to show you really quickly what happens when they do it improperly. So here's a little video. This is right here in Minneapolis, right off of Highway 36, I think. So just watch this inside lane. Just a second and it'll pop up. Watch the inside lane of traffic coming at us. Almost there. Not yet. Here it comes. You're going to see someone tailgating right about now. Watch the tailgaters. Okay, you saw those cars fly up a little bit. That's because the roads started to buckle. So we don't want the roads to buckle, so we intentionally create little gaps in the road that allow for them to expand and contract. So let's get started with this problem on linear applications building bridges. So they put the gaps there so the bridges will have room to expand when the weather gets hot. Suppose that the bridge has a gap of 1.3 centimeters when the temperature is 22 degrees Celsius. And when it warms up to 30 degrees, it is 0.9 centimeters. So when it gets warmer and warmer and warmer, the gap shrinks. We want to come up with two coordinates that we can write from this information. So we're going to write them kind of backwards. The temperature is what determines the size of the gap. So I'm going to put the temperature first. So this would be 22, 1.3. And for the second one, the temperature is 30 with a gap of 0.9. So the temperature is the x, and the y is going to be the gap, because the temperature determines the size of the gap. So the x coordinate, that's this 22, and this 30, that's the temperature. I'll just put the temperature, and I'm going to put degrees Celsius, because you can measure temperature in different ways. We're making sure this is in Celsius. The y coordinate, that's going to be the size of the gap. So you can see in this picture here that they have this gap here, and it allows for expanding and contracting. Next, it says to calculate the equation of the line that represents this scenario. So just to save time a little bit, I'm going to go ahead and pause the video, and then when I come back, it's going to have everything there. So you might want to pause it and then copy it all down, or just try it, make sure that yours matches with mine. So I'm going to pause the video here, and I'll be back in a second. Okay, welcome back. Here is how you find the slope. We end up with a slope of negative 0.05. We'll interpret that in a second. Here is how you calculate the y-intercept. And once you've done that, we get our final equation. And the reason I kind of glossed over this is we focus more on the interpretation part of this now. Hopefully, you're comfortable solving for that equation. So for part D, it says, what is the y-intercept of your equation? And the y-intercept is 2.4 right there. So I'm going to write it as a coordinate. The y-intercept is 0, 2.4. And remember, this is the x coordinate, and this one is the y coordinate. And the x coordinate in this case, we defined it earlier, that's the temperature. So when the temperature is 0 degrees Celsius, now 0 degrees Celsius is, we're probably more familiar with 32 degrees Fahrenheit. So pretend it's a chilly morning, it's 32 degrees, you maybe got to throw a jacket on to stay a little warm. So it's 32 degrees Fahrenheit, but that's 0 degrees Celsius. When it's 0 degrees Celsius, the gap size, that's your y coordinate, is 2.4 centimeters. So I'll make a note of that. When the temperature is 0 degrees Celsius, the size of the gap is 2.4 centimeters. It's not a very big gap. It's not like you're going to fall through or anything, but there is a gap there which allows it to expand. So that's when it's nice and chilly. When it's 0 degrees, the gap is 2.4 centimeters. Now we get to this one here, and again, the slope is one of the more important ones that we want to focus on for our interpretation. So what is the slope? And there's a couple ways you could do it. I think this way might be easier to interpret. So if you think of it as negative 0.4 over 8, remember this is the change in y, that little triangle means the change, and this is the change in x. So what this part is saying is the size of the gap is shrinking by 0.4 centimeters as the temperature increases by 8 degrees Celsius. So you could say the gap shrinks or decreases by 0.4 centimeters for every 8 degree Celsius increase. One other way that we could have interpreted it was we could have used that other decimal. We could have used that negative 0.05. Think of this as like negative 0.05 over 1. So what this means is the gap is shrinking by negative 0.05 centimeters for every 1 degree Celsius. So by reducing it, it goes down to every 1 degree Celsius. However you want to interpret it, as long as it's correct, that's fine with me. Let's move on to part F. We have calculate the x intercept of this scenario and what does it represent. So I'm going to start with my equation. Y equals negative 0.05x plus 2.4. And remember to calculate the x intercept of this. Any x intercept is where the y coordinate is 0. So let's set that y to a 0. And then we have to solve for x. So let's get rid of that 2.4. We're going to subtract 2.4 from both sides. And 0 take away 2.4 is a negative 2.4 equals negative 0.05x. Then, to get rid of the negative 0.05, right now it's multiplying. To get rid of it, we have to divide. So we're going to divide by negative 0.05. And when you do that, we get x equals 48. 48. Now we have to interpret what that means. And again, it's easier to interpret if you write it as a coordinate. So let's write it as a coordinate. We have 48, that was our x, and we knew that the y was 0 because it's an x intercept. So now we can interpret this. Remember, this is the x coordinate, that's your degrees. So when it is 48 degrees Celsius, 48 degrees might not sound like much, but when you're talking about Celsius, that's actually quite a bit. So that's probably when it's like, I don't know, 120, 130 degrees, maybe even more, I don't know. But when it's 48 degrees Celsius, the size of the gap has shrunk to, 0. That's your y coordinate. There is no more gap. So remember, the x-intercept is kind of like your ending point. So when the temp reaches 48 degrees Celsius, we don't have to worry about that happening in Minnesota too often. When it reaches 48 degrees Celsius, the gap is 0 centimeters. It is gone. And that's when it's going to be so hot that that road starts to buckle, and then some bad things can happen. So hopefully these people building the roads are doing their job correctly and they're measuring things properly, and then they're going to make it so that doesn't happen. All right, part G. It says, how wide will the gap be at negative 10 degrees Celsius? So let's go ahead and use our equation. Y equals negative 0.05x plus 2.4. And now the information that's given to you is that it is negative 10 degrees Celsius. So if you go back way up here to part B, the temperature is an x coordinate. So I can take this negative 10 and I can replace it for the x coordinate. So we have y equals negative 0.05 times negative 10 plus 2.4. All we did is replaced the x with a negative 10. And we have negative 0.05 times negative 10. That gives you a positive 0.5. When you multiply two negatives, it makes a positive. And then we add the 2.4. And if you simplify 0.5 plus 2.4, it is 2.9. Units there are going to be centimeters. So when it's really, really cold outside, negative 10 degrees Celsius, that's getting closer to like, 10 degrees Fahrenheit, somewhere around there. That's when the gap starts to get bigger because the roads have shrunk a little bit, so the gap between them is now bigger. So that's why you see it as 2.9 centimeters. The gap is growing. So there is your size of the gap when it's negative 10. And finally, at what temperature will the gap be 0.5 centimeters? Let's start with our equation. We have y equals negative 0.05x plus 2.4. And in this case, they're saying that the gap is down to 0.5 centimeters. Remember, the gap size, that's the y coordinate. So I can replace y with 0.5. And then we have to solve for x. It's asking, what's the temperature? X is the temperature. We're going to try and find it. So let's go ahead and get rid of this 2.4. We will subtract 2.4 from both sides. And 0.5 take away 2.4 is a negative 1.9 equals negative 0.05x. And then we can take negative 1.9 and we can divide it by 0.05, negative 0.05. And when we do that, we get x equals 38. And now remember the units on here. This is degrees Celsius. So when the temperature is 38 degrees Celsius, the size of the gap it's getting pretty small. It is only 0.5 centimeters. So that's starting to be cause for concern there. Once again, use Desmos, create this graph. I think hopefully by this time you're probably okay with that. So that is it for building bridges. You've got one more to do on your own. Make sure you're comfortable with that. And then you've got your unit test between Wednesday and it is due on Friday. Good luck, everyone.